Hello, software programmers. Today I'm going to go through an article which I found very interesting. It's a very good article because it has got a lot of good tips around it. But I thought I would go through this because I can explain some of the nuances and some of the practical tips that you can put in so that you can reach the stage where this article is looking at. So let's deep dive into this. So the name of the article is 10 advanced coding practices Java seniors live by. It's a big claim there, but it delivers to its promise to a great extent. Let's go through this. The first one is writing self-documenting code. Now it talks about writing good comments and then having a messy code, which is a bad part, and then they rewrite it with a better way, with better naming function. If you look at the name of the method, it says calculate price with tags, so that's very clear as to what this particular method is doing instead of the earlier one that is out there. But what I want to bring to you here is that although this is good, there's one more caveat into this. Now, all comments are not bad. Yes, it's good to have the self-documenting code, but then there are certain types of comments that are required. Some of the examples are the first one could be writing an interface. Like for example, you have implemented an interface and you want to give the consumer of the interface the explanation of what the interface is doing, what is it expecting, and what are the constraints around it. So that would help other developers use that interface. Similarly, for public methods that you have, because other consumers are going to access it, so you need to tell them what this method is this for. The second reason where you could possibly have comments is where you want to explain the why. Sometimes you write a code and you know why it has to be done, and it looks a little bit weird when people look at it, and they might be wondering why this is happening. So during those places, that is where you add that comment saying why you are doing this. Or then the other scenario is sometimes you might just check in an empty method saying that it will be refactored or implemented at a later point of stage. So might you want to add it to do, although that would be only for a very exceptional business case that you might be looking at. So these are some of the places where you really want to have the comment. You want to write the self-documenting code as the author says, but then you also have to be mindful of the fact there are some good comments and then some bad comments, and good comments are required. It might not be self-evident, and that is where you need to bring your thinking up. Like, would a developer 6 months down the line understand this code? Would they need more assistance, or would they need feel that this is too complicated or this is something weird that you have implemented? So that piece of comment that you put in there, that will save a lot of time for that particular developer. So that is a key point I want to bring to this here. The next point, we'll go to the next point. The next point is embrace immutability wherever possible. So this is a good one that you need to do it. Now the author has given an example how to do it. Like there's a getter than setters and there's a list, and what happens is anybody could go and add or modify that particular list, and they have given a implementation where they showed how you can make it unmodifiable so that nobody can modify it, a particular list. They would have to create a new instance of it. So that's a good practice out there. But I want to add a little bit more onto this because this is a good practice. But then how do you know when to make it immutable or when not to be immutable? Now the author has suggested that you make it all of them immutable by default, but then that defeats the purpose, right? Because there could be a scenario where it should not be immutable. You want it to be not to be immutable. So how do you decide? Well, that comes from the intention of the class. So when you create the class or when you create these member variables, you need to understand why you are creating it, what the context they are going to be used, and so on. So once you have that clarity, then it helps you make that decision whether you want to make it immutable or not. Once you've taken a decision, goes into the class, what is the purpose of this class, what is the purpose of these member variables, then you can decide whether this needs to be an immutable or not. Maybe your answer more often than not lie with going ahead with immutability, but having that question will make sure that you are thinking about the problem rather than blindly copying some particular practice out there. So that was what I wanted to highlight. The next one we will go here is designed for testability from day one. Now, if you look at this, the author has shown that a certain class that is going and connecting to the database and saving an order, and then it is sending a notification. And then he mentions this untestable garbage he wrote, and he approaches it with a very different approach where we call order or repository, which that deals it with the DB connection, and then notification service deals with the notification part of it. And that way, order process does only one thing. So the idea here is the order process should follow the single responsibility principle, and that is where you can get the testability what the author is looking at. Now, the other aspect of this particular thing is, as a senior dev, this thing comes out of the box. Like the moment you see a database, yeah, you know that you will go and create an order repository, and you see that there's a service that's in notification, you create a new service. But how do you reach that point where you will know how to do this? This is where I'm going to show you how to do it. The way you do it, you first write that garbage code that you're out there. Now, this is a challenge that people who are just starting out might be facing it. People who are experienced might not face it. So what you do is you go and write that garbage code and write tests for it. Now, when you start writing tests, you need to mock. Now, if you look at the example the author has given, you can see that he has given a lot of mocks. Similarly, when you try to test that garbage, you will find that you need to write mocks. Now, as you start writing mock, you feel that certain parts of it doesn't fit here. It has to go somewhere else. And sometimes you might feel that you need more powerful mocks, like because there might be private methods that you need to mock or some advanced power mocking that you need to do. Once you start getting that feeling, you feel that is when you know that the responsibility of this class has become too much. That's where you need to branch out to another class, and that the logic of that sub logic go into that new class, and you can test that class properly. That's how you arrive at the point of having testability from day one. It cannot happen out of the blue. You need to have this process that you follow so that you can reach it. So that I thought I would highlight that particular approach out there. The next one is about favoring composition over inheritance. So if you look at this example, yes, the author has again given a very generic example now about how inheritance has been implemented, and then there's another example where you implement it to the vehicle, and now you have to do with the boat, and it all breaks the inheritance circle. So you go and implement composition, which makes it much more flexible and working to it. Now, the key nuance that I want to highlight here in this particular approach is that you don't start with inheritance or composition on the day one. You might not have all the requirements out there which will tell you that this is where you need to use inheritance, or you might need composition. Most of the time when you're working, you don't have that visibility. You might have just one use case or a couple of use cases that you have to implement. At that point of time, I would still suggest to go and write the code as is. Don't worry about inheritance or composition at that point of time. Now, as the time goes on, the complexity starts increasing. There are more use cases coming, and you will start getting clarity of the domain that you're working on. And at that point of time, that is when you decide when you want to use the implementation or you want to go over composition. Obviously, the author has suggested that you can go with composition, and that's a little bit easier approach to do it and a cleaner approach. But then that decision comes out from the patterns that you have been observing over a period of time. You don't start out by writing these inherited classes and all those things. You know why? The reason why? Because when you're starting out in a new project, the requirements are new. At that point of time, you don't know the trajectory of the project it's going to. Sometimes what you would have done is you would have expected a particular set of requirements coming in, and you write this beautiful composition and inheritance all working together. And then what happens? Suddenly 2 months down the line, you get a requirement that breaks everything, and then you just need to refactor all the things that you have done. So the better approach is you start simple, and as you find more patterns, you go and implement inheritance or composition how based on how the domain is working. And so yeah, that's the another one that I wanted to do. The next one, handle exceptions with purpose. So if you look at this code, I mean the whole idea is this code is throwing or could throw multiple exceptions, and there's a generic exception that is being caught. Now the one way of doing it, like you can have multiple catch statement that you could do it, but then the author has given a good approach where he has created another method that is specifically designed to handle a specific exception. And then there's a another one which handles the generic exception. So this is also follows, if you have read Uncle Bob's clean code, you need to have your exceptions as a separate from the logic, so that it becomes clearer for people to read it. You can still make it a little, but that is a little bit more, I would say, dogmatic. I think this is a much better approach, I feel. So the other important part I want to highlight on this is, he talks about this point: never swallow exceptions without logging. Now you might be wondering, what are the scenarios where you would need to, swallow an exception? Isn't throwing an exception all the time should be the norm? Well, there are certain scenarios where the client doesn't care whether it has exception as a con. So assume there's a bad job that is running, and this bad job goes and delete unused accounts for your customer. Now, the thing is, there could be scenarios that the bad job runs multiple times, and then it will try to delete an already deleted account. Now, in this scenario, what happens is, if you try to throw an exception, it will throw an exception until the bad job will stop, and all the entire thing gets stopped, and your processing gets stopped. But the thing is, in this scenario, if you are able to follow that exception, what that does is the bad job continuously goes in, because you don't care whether the account, I mean, whether the account is present or not. If the account is not present, that is what you want, because the whole crux of the operation was to delete that account. So, in that particular scenario, it's better to just swallow the exception. Obviously, you need to add the logs, because the logs will tell you whether there's an other problem or underlying problem in the way you are running the batch. Because if there are a lot of such errors, it means something you have done wrong, and you can kind of put a fix in around that. That was the key point here. Going to the next one: optimize for readability, not cleverness. Again, this goes in the naming or writing clean code bucket. You see there's some clever code that's written, and then he has implemented a much better approach where you call what you're doing, whether you're checking for even, whether you're checking positive. Now, the thing is, if you're writing it for a specific business domain, in that scenario, I would suggest to give the names related to the domain. You know, has the account been deleted? Is account present? And so on. So because when you put that in, you are actually embedding the business rules into that logic. So when you see the anybody reads that code, they will understand the business logic, and it becomes clearer to them why you have done that particular thing. So that was one tip on this approach. And I'll give a small example from my past. Like when I was learning C for the first time, I was very confident about my ability, and I would start. There was a, I don't know what forum it was, but there was a website where they would give this obfuscated C code, and we had to figure out what the output would be. I used to enjoy them because it looked like puzzles, but now if I look at it, I wouldn't do that, because it just defeats the whole purpose. Yes, it looks clever, but then it is very hard to decipher. And if there's a production issue out there and somebody has written such kind of code, you would just blow your head around it. I don't know what curses you'll be throwing out, but it's pretty hard at that point of time. We'll go to the next one. Yeah, there's again the power of good naming. As I said, there are 3 points around good naming or clean code, and it's again the same thing that he has talked about. That you give a better name so that people can understand about it, and they can respond to it, or they can feel what's happening within that code. One caveat I would say, there was a comment on this saying that, you know what, if you put validate customer address and then there's a shipping address, both of the things are validating the address, so you should be having make it more generic. I would suggest that you have it generic, but you still wrap it with, say, validated customer address or valid shipping address, and underneath it still calls the generic method. The reason is, in that specific domain, having that validated customer address makes sense, and not the generic one. And similarly, the other way around. So that would help people understand, okay, what address we are validating. The next one is write defensive code, and but don't go overboard. Now, there's a big spectrum here that we're trying to cover. There's one spectrum where you add lot of null checks, if conditions, so that nothing breaks. And there's the other end of the spectrum where you are trying to not you're not worry about the problem. You feel that there is not going to be an exception conditions. The reality, as usual, always lies somewhere in between the middle. So how do you reach to that particular point of time? So this is where the knowledge of the business domain context comes into the picture. You need to validate yourself where, for example, it is a good practice to have validation at the input layer. So when your API is being called, you put it the validation there, but then the subsequent or the internal workings of it does not need that validation because you already validated out there. So there's no point of validating it again. So that way you reduce the number of those if conditions, but you're also achieving the defensive programming part. So that is how you have to look at it. The other aspect of defensive program is looking a little bit in future, but not too far ahead. You can always think about scenario. What if someone does this? What if someone does that? What if someone just does this? Then it becomes an infinitely complicated code of if and else out of it. But what you can really practically do, like maybe you can see 3 months down the line, what are the requirements coming in, how is it going to be used, how is it going to be modified, maybe 6 months down the line. So if you have that visibility, or if you get that visibility from the business or the domain, then you can put those specific validation that will help you to get that information. To make your code more defensive around it. The next piece is leveraging functional programming concepts. So this is one of the cool things about Java. Java has pulled in all the functional programming concepts which people talk they are cool about in other programming languages, and that's why they are avoiding Java. So Java pulled them in, so you can leverage them, and I would say you should leverage them because it makes the code more readable and it's more cool to do that, and it's really fun to write that code. And one of the advantage that it gives is it supports parallel processing, and it reduces mutable state. So again, going back to that immutability principles that we have. Now the last point that we have is about continuous learning and code review. Now if you want to take away one thing from this particular video above everything else, is to take this line in contention: regularly read other people's code. The more you read other people's code, the more you learn, and you learn much faster. Whenever you join an organization, try to read all the PRs, the pull requests or the merge requests that are coming through, because the more you read those code, you learn those code, how the people are thinking. And the thing is, you can straight away apply those principles and practices into your coding. Over a period of time it will become natural, and then you become fast. And the beautiful part is, all the top 9 points that you have, they all get covered in this particular line, because the moment you implement these sentences, other developers are already following other 9 things most of the times. So when you are joining, you can really learn from them, pick from them, and then improve your own coding on this thing. So this is one of the most key aspect of it. And for the next, like, 6 months, you are trying to improve your writing code. Just focus on this. Read as many pull requests that you can find, read as many merge requests, and try to break that code. Try to make it more, try to make it more readable, or try to put different methods in different exceptions, or try to change the approach that have been implemented. Because when you try to break that, that is when you get the maximum learning. When you're just doing a static scan, you will get an learning, but you will not be able to really understand why it's happening. But when you try to break it, put a different approach to it, or put a different spin to it, or use a different library, you will start seeing why the other developer would have done it, and you start appreciating the beauty of that particular code. So that's one of the biggest takeaway I would say you take with this particular uh, article that I've gone through. Apart from that, yeah, so that's all from this. So the whole idea of this particular post was to cover the nuances and the best practices. Some of the key nuances are about the code commenting. Just ensure that there are good comments and then there are bad comments. You write self-documenting code, but then you also have write good comments so that people are able to understand what's happening. Then you follow the clean code naming functions, naming conventions. You name variables or methods with the intention that you want to use it for, so that people understand. And similarly about immutability and exception handling, they all come under the bucket of the clean code. And then the last bit is about functional programming. And yes, you go and learn about functional programming, and then you try to implement it. The other day I used a functional programming concept of by passing a function into an argument, and the code looks so cool. So that's why I'm saying just learn through it, read from other people's code and get onto it. And that the read other people's code is the takeaway that I want you to take away from this particular video. All right, so that's all from me. Now if you like this video or you want to see more, just say hi to me in the DMs, or follow me on the social channels that are there on this post. Thank you. Bye.